In lesson 6.6, you will solve radical equations. And in this first example, we're going to solve the equation for x. And remember to check our solution because solving radical equations could produce extraneous or false solutions. So to solve this first equation, we want to isolate our radical term. So I'm going to start by adding that fourth root of x to both sides of this equation. So that I have 5 is equal to the fourth root of x. And now I need to get rid of the radical, and to get rid of the radical I have to raise both sides of this equation to the fourth power. Because this radical times itself 4 times is just going to be x. And on this side I have 5 to the fourth power, which is 625. So the solution that I'm getting is x is equal to 625. Now if I check that solution in our original equation, I'm going to substitute 625 in for x. And I'm going to simplify on the left hand side here. But the fourth root of 625 is 5. And 5 minus 5 does equal 0. This is a true statement, so it tells me that my solution checks. X is equal to 625. Okay, in the next equation, instead of a radical, we have a fractional exponent. But remember, a fractional exponent is nothing more than a radical. To solve, I want to get that x to the 4/3 power alone, so I'm going to start by dividing both sides of this equation by 3. And over here I'm going to get 81 when I divide. And now, to get rid of that fractional exponent, all I have to do is raise both sides of this equation to the 3/4 power, which is the reciprocal of 4/3. Because when I multiply these double powers on the left, 4/3 times 3/4, they're reciprocal, so their product is 1. So I have x to the first power, and it's equal to, and now I'm going to change from that fractional exponent to a radical, because I have the fourth root of 81 raised to the third power. Okay, so x is equal to, I know the fourth root of 81 is 3, and 3 cubed is 27. So x should equal 27. And I'm going to check in that original equation. So I'm going to substitute in 27 for x. And I'm going to change now to a radical, change that fractional exponent to a radical. So I have the cube root, the third root of 27 raised to the fourth power, and that should equal 243. So let's simplify to find out. So I've got 3 times, the cube root of 27 is 3, and that's 3 to the fourth power. 3 to the fourth power is 81, and 3 times 81 is 243. So again, I get a true statement, and I know that I found the correct solution. X equals 27. Okay, in the first example on this page, we need to isolate our radical. So I'm going to start by adding 4 to both sides of this equation so that I have my radical alone. The square root of 2x plus 8 is equal to 6 plus 4, which is 10. Okay, now to get rid of my radical, once it's alone, I want to raise both sides of this equation to the second power. Since this is a square root, I'll need 2 of them multiplied together to get what's inside. So now I just get 2x plus 8 is equal to 10 squared, which is 100. And now I can subtract 8 from both sides, leaving my x term alone. So I have 92 on the right. And the last step is to divide both sides by 2 to get x alone. So x should equal 46. And I'll check to make sure that that's a good solution. So in that original equation for x, I'm going to put 46. And I'm going to simplify that left-hand side to make sure that it equals 6. So underneath this radical, I've got 2 times 46, which is 92. And then underneath that radical, I have 92 plus 8, which is 100. And we know that the square root of 100 is 10. And 10 minus 4 is equal to 6. So I get a true statement again, and I know that my solution, x equals 46, is good. Okay, in this next equation, there's 2 radicals, and they're not like radicals, so I can't combine them. What I need to do is separate them. So I'm going to start by adding that 3 square roots of 2x to both sides of this equation, so that I have positive 3 square roots of 2x on the right. And now I can square both sides of this equation to get rid of my radicals. This radical times itself is what's inside, so I get 4x plus 28 on the left. And over here I have to square 3, that's 9. And I have to square this radical, and that radical times itself is 2x. Okay, so now simplifying, I have 4x plus 28 is equal to 18x, and I'll subtract that 4x from both sides. So I'll have 28 is equal to 18x, take away 4x, which is 14x. And now dividing both sides by 14 to get x alone, I find out that x should equal 2. So I'll check that solution in the original equation. I'll substitute 2 in for x. And simplify that left-hand side. So underneath this first radical, I have 4 times 2, which is 8. And in this second radical, I have 2 times 2, which is 4. So now I have the square root of 36 minus 3 times the square root of 4, which is 2. And we know that the square root of 36 is 6, and negative 3 times 2 is negative 6, and 6 minus 6 is 0. So again, we get a true statement, and our solution checks. X equals 2 is a good solution. Okay, in this third equation, our radical is already alone. It's a square root, so all I have to do to get rid of the radical is to square both sides of this equation. But on the left, I have a binomial times itself. That's going to be a trinomial, because I'm going to have x times x, which is x squared. And then I'm going to have x times 2, which is 2x, but then I'm going to have 2 times x again, which is another 2x. So 2x plus 2x is going to be 4x in the middle. And then 2 times 2 is 4. So that binomial squared is equal to this trinomial. And on the right-hand side, this radical times itself is what's inside, 2x plus 28. Okay, now we have a quadratic equation to solve, so we want 0 on one side. So I'm going to move 2x and 28 to the left-hand side. I'm going to first subtract 2x from both sides, so 4x minus 2x is 2x. And then I'm going to subtract 28 from both sides, and 4 minus 28 is negative 24, leaving 0 on the right. Okay, now our method for solving this quadratic equation would be to first try and factor and use the zero product property. And remember, if it doesn't factor, then I'll have to use the quadratic formula to solve for x. But I need factors of x squared first, and then I need factors of 24 that have a difference of 2. Well, that should be 4 and 6. And I'll make the 6 positive because the middle term is positive in my trinomial and the 4 negative. And when I check, negative 4x plus positive 6x is positive 2x in the middle, and negative 4 times positive 6 is negative 24. So it's factored correctly, and now I can use the zero product property and set those factors equal to 0 and get my two solutions for x. So I'm finding that x could equal positive 4, or over here x could equal negative 6. But I need to check my solutions, so I'll first check positive 4. So I'll put 4 into that original equation for x, and I'll see if I get a true statement. So I have 4 plus 2 or 6 on the left, and on the right hand side underneath this radical I have 2 times 4, which is 8, and 8 plus 28 is 36. So I have 6 is equal to the square root of 36, which is 6. So I get a true statement, and I know that x equals 4 is a good solution. And I still need to check negative 6. So I'll put negative 6 into this equation for x. And simplify. But negative 6 plus 2 is negative 4. Now I know right now that the square root of this number is not going to be negative. But I'll simplify just to see what we get. 2 times negative 6 is negative 12. And negative 12 plus 28 is equal to 16. And the square root of 16 is positive 4. Negative 4 does not equal positive 4. This is a false statement. So I know that negative 6 is not a good solution to this equation. The only good solution is x equals 4. Include with your notes of this video guided practice problems 1 through 13 odd on pages 452 through 455 of your textbook.